Greetings, YouTube. I am currently watching the Fallout series. In fact, I've only watched the first episode. But by the time you see this video, I will have finished it. These videos are filmed often 6 or more months in advance um, because I have to film them when I have the ideas. Sometimes they come fast and thick, and sometimes they don't. And I don't know the secret that's going on between Vault 32 and 33. It is the only instance of in Fallout canon that I'm aware of where two vaults were right next to each other. And I mean, literally, their doors were across the hall from each other. And they were kept in isolation. I don't know why. And they have a policy of exchanging mates. I guess for genetic viability. Though if you both have a small population, doing that doesn't get you much. But I started thinking about this. What if you have a small population and you want it to remain as genetically viable as possible? And you have lots of time, that's easy. If you have less time, it's a little harder, but it's not impossible. You can avoid inbreeding. So if you're looking really long game and you have plenty of time to set up for this eventuality, say you are a real company as opposed to Vault-Tec, which is just a cruel, twisted, warped company whose purpose is to cause suffering and pain upon others while they conduct twisted experiments that I'm not sure anyone is ever actually going to see the results of, because I don't know if anyone from Vault-Tec is still alive out there collecting said data. They just seem to be evil and a great example of late stage capitalism. Um, but let's say you have planned for this eventuality. What you can do is you can collect genetic material. You get as many genetic samples, eggs and sperm samples, as you can lay your hands on. Tens of thousands of them if you can. So when it comes time to button up the old vault and push your population, and we're going to say it's a nice round number like 200. So that's 100 couples. Now I realize that statistically, 20 of those people are not straight. There's something not straight. So actually having children the old-fashioned way might be something they want nothing to do with. But you've got in vitro fetal fertilization. So IFV is a thing. So that you can use that method. And we know they have the ability to preserve sperm and eggs really long term because they have the ability to preserve humans long term, something that we can't do, and we can preserve eggs and sperm long term. So if we can do it, they can do it. All right? But let's say you don't have time for that. Say you have to get in there and button it up, but once you're in there, then you can start doing the same thing. It's just now you have a smaller pool. You start to collect as many samples you can from every single member of your community. As many eggs as the people who have wombs can produce that they aren't using to actually, raise a kid, and as many doses of sperm as can be produced, which is a much higher ratio than eggs because penis havers would be like that. Um, and you preserve those. Now, the first generation, you just let people have what they want. And let's say you planned on a total population of 300. So you gave yourself 50% expansion space, and you have the food and the resources to cover that. So the first generation, you have everybody can have 2 kids, and then you say you have a lottery and a people who put their name in who want to have a third. So you have a few more people than you do, but not a huge number. And you keep doing this. Every generation, everybody can have 2 kids. And if they don't, they can still contribute to the genetic bank that you've got. And then you have a lottery to see if they want more than two. You also would inadvertently be breeding for luck. Niven talked about that. Um, the luck of Tila Brown. Um, but when you get to the second generation, one of their kids can be done the old-fashioned way, but the other is going to draw from the bank. And you keep doing this, constantly drawing from the bank. Now, eventually, you will use up all of the bank from the first generation. But then you have the second generation to draw from. And if you do this long enough, you will continue to have a genetically viable population and reduce the chances of inbreeding to a minimum. Now, this is also going to have to require you to terminate a lot of pregnancies. You'd have to do that anyway. Even if you weren't using this plan for genetic viability, you can't let people just have children willy-nilly because you are in a closed system. You have a limited supply of food. You have to make sure that everybody can survive. If they're allowed to breed indiscriminately, they're going to starve you all to death, which is not a good thing. Um, but the plan I'm talking about would work. Now, if you have the long-term plan I talked about and at the beginning, when you have tens of thousands of samples, then you're never gonna have to worry about, never gonna have to worry about genetic uh, incompatibility ever. You just keep pulling from that bank. So you keep getting new material from the past. And that means you're always going to have a strong genetic pool. You're not going to have to worry about inbreeding. Because if you have a small group, like they seem to have in faults 32 and 33, it doesn't matter how much you exchange from one side to the other. Eventually, you're all going to be related. And hopefully the pool was large enough that that is going to have minimal effects, but it can have dangerous effects, particularly if there are recessive genes that you didn't know about at the beginning of this process, and they become reinforced over time. I think, for example, one of the things that's always fascinated me is sickle cell anemia. Sickle cell anemia is a deadly disease, but for someone to have it, both their parents have to carry that gene. And if they don't, they're not going to get it. So why does this gene survive? It survives because people who have that gene are better at resisting malaria. So it was a short-term protection, and that's all your alleles care about, short-term protections that had long-term consequences for a population. So the alleles in your system in that area were making a gamble saying all we care about is making sure that there is another generation and don't seem to be cared about the fact, aren't concerned with the fact that there's a problem that pops up in the third or fourth or fifth generation down the line. So that's how genetics works. There is no planning involved, folks. It just happens and things work out the best they can with what they've got. And sometimes it's a success and sometimes it isn't. There are a lot more genetic dead ends in the universe than there are success stories. So what would you do if you wanted to keep a population viable long term in a closed environment like a vault or a generation ship or even a small colony when you get to a planet and you still have the same problem, which is you don't have that much material to work with. So you're going to try to uh, do the best you can to keep the people as genetically diverse as possible. Let's talk about genetic diversity in science fiction.